Here is an aeroplane that is making a curve. It just departed Salt Lake International Airport. How do you measure the speed and the distance from the aeroplane that is making a curve? We discussed before how to measure it, the speed and the distance from you if the aeroplane is making a straight line. But in this case, it's too complicated, so you have to depend on differential calculus. You simply have to make a device that uses microcomputers like Arduino. You have two different options. You can either use a sound detector that is automated to change the angle. The sound detector can change the angle depending on the intensity of the sound. Even in that case, because you don't have a linear problem. A linear means the aeroplane have to be flying in a straight leveled line and you have to be perpendicular to it. But if the aeroplane is making a curve, your project have to be an Arduino that's controlling a sound detector and a camera, or just a sound detector and a timing device, a timing electronic component. So the sound detector, here is another airplane that's taking off. The sound detector will measure the angle of the intensity against the intensity, and you are going to have a curve. You can either plot the curve or you just keep the curve in a. This aeroplane is making a curve. So you are going to have a curve or a function between the angle and the intensity, the angle between you and the aeroplane and the intensity. Of course, you are going to have another curve between the angle or the intensity of the aeroplane and the time it took to cut different angles. So you have two functions. Intensity versus time and intensity of the sound, that is the sound of the engine of the aeroplane, versus the angle it makes. From the two functions, you can differentiate to get the speed of the aeroplane, that is from the curve of the intensity and the angle, and the distance of the aeroplane, that's from the curve of the intensity and the time. Because when you multiply the time by the intensity, you get a distance. When you multiply the speed by angle, you get the speed of the aeroplane. That is a differential calculus problem. It's a simple problem, it's not complicated, but you just have to calibrate your equipment such that you get increments of measurement of angles and time that can make you have to plot a smooth function. Then you do a regression on the function. A regression means reconstruct the function in an equation format instead of trying to measure point by point. And you can get instant reading on the screen without having to do your calculation by hand. If you use only a sound detector with an automated against the angle, you can measure the speed of the aeroplane in the dark. You don't have to see the aeroplane to measure its speed if you can automate your equipment to trace the sound. If you are going to use a camera and a fixed sound detector, in this case the camera can find the location of the aeroplane, whether the camera itself is going to be also automated to rotate with the aeroplane, to trace the aeroplane. That is all visual and acoustics. We are not using here radar. Of course, if you use a radar, you can get different. The radar is the problem, you have to have a good antenna. The sound, the problem, you have to have a quiet environment. Even though the sound, you can still filter the sound to amplify the engine, the jet engine of the aeroplane.